In the summer of 1977, as disco filled the airwaves and the Cold War loomed over geopolitics, humanity launched one of its most daring and visionary experiments, not in military power or global economics, but in exploration. Two spacecraft, built by NASA engineers, were sent on a mission so ambitious it would stretch the bounds of technology, science, and imagination. Their names? Voyager 1 and Voyager 2. They were never meant to return. They were never meant to land. And yet, they were destined to become two of the most successful and transformative missions in the history of space exploration. Decades later, the Voyagers are still out there, silent ambassadors traveling through the darkness, bearing with them the legacy of all humankind. This is the story of the Voyager mission, a story of science and spirit, of technology and tenacity. A story of how two spacecraft transformed our understanding of the solar system and began a journey into interstellar space. Let us begin with the dream. In the early 1970s, NASA scientists recognized a rare opportunity, a once-in-176-year alignment of the outer planets. Jupiter, Saturn, Uranus, and Neptune would be positioned in such a way that a spacecraft could slingshot from one to the next using gravity assists, a grand tour of the outer solar system. It was a narrow window, and the technology to take advantage of it had to be developed in record time. The result was the Voyager program, two twin probes designed to be tough, smart, and adaptable. Each was fitted with cameras, magnetometers, plasma detectors, and cosmic ray sensors. But the Voyagers were more than instruments. They were emissaries. Carried aboard each spacecraft was a golden record, a 12-inch phonograph disc encoded with sounds and music of Earth, greetings in dozens of languages, and a map to our home. The idea was simple and audacious. If an intelligent species were ever to find Voyager, they would know not only that we existed, but that we had reached for the stars with curiosity, compassion, and creativity. Voyager 2 launched first on August 20th, 1977. Voyager 1 followed on September 5th. Their trajectories diverged, but their destinies were intertwined. Within months, the first images and data began flowing back to Earth, a trickle of discovery that soon became a torrent. Jupiter was their first major stop. In 1979, both Voyagers flew by the gas giant and revealed it as a world of storms, moons, and magnetic fury. Voyager 1 sent back images of Jupiter's Great Red Spot, a storm large enough to swallow Earth, as well as intricate cloud patterns and auroras dancing at the poles. But it was Io, one of Jupiter's moons, that delivered the first true shock. Voyager discovered active volcanoes erupting on its surface, the first evidence of ongoing geological activity beyond Earth. Until that moment, the universe had seemed cold and still. But Io changed everything. The solar system was not dead. It was alive. Then came Europa, with its smooth, icy surface and hints of a subsurface ocean. It would take decades for Europa to be fully appreciated, but Voyager laid the foundation for what would become one of the most promising locations in the search for extraterrestrial life. Next, the probes moved towards Saturn. In 1980 and 1981, they approached the ringed planet, and once again, they rewrote our understanding. Voyager's images revealed that Saturn's rings were far more complex than anyone had imagined, composed of countless ringlets, twisted and braided by the gravitational tugs of shepherd moons. Saturn's largest moon, Titan, proved especially tantalizing. Voyager 1 attempted a flyby, but its instruments couldn't pierce Titan's thick atmosphere. Still, What was learned was enough to inspire future missions like Cassini and Huygens, the next generation of planetary exploration. For Voyager 1, Titan was the final stop. Its trajectory carried it northward, out of the plane of the solar system, and eventually into interstellar space. But Voyager 2 kept going. In 1986, it became the first, and still only, spacecraft to visit Uranus. It revealed a pale blue world tipped on its side, surrounded by dark, narrow rings and moons with mysterious, icy surfaces. Voyager 2 showed us Miranda, a moon that looks like a jigsaw puzzle of planetary geology. Then, in 1989, Voyager 2 approached its final planetary destination, Neptune. There, it discovered winds faster than any measured on Earth, and a dark storm system later dubbed the Great Dark Spot. Voyager's encounter with Triton, Neptune's largest moon, revealed a frigid world with geysers of nitrogen ice, another sign that even in the deep cold, planetary bodies could remain active. By the 1990s, both Voyagers had completed their planetary missions, but they were not finished. NASA reclassified them as part of the Voyager interstellar mission. Their new task, to study the edge of the sun's influence, the heliosphere, and to continue sending data until their power ran out. In 1990, at the suggestion of Carl Sagan, Voyager 1 turned its camera back toward Earth and took a final photograph, a tiny dot of light suspended in a beam of sunlight. That image became known as the pale blue dot, and from that image came Sagan's immortal reflection. Look again at that dot. That's here. That's home. That's us. It was a poetic coda to a scientific odyssey, but the mission wasn't over. In 2012, Voyager 1 became the first human-made object to enter interstellar space, crossing the heliopause, the boundary where the solar wind gives way to the interstellar medium. Voyager 2 followed in 2018. Even now, both spacecraft continue to send data, whispering across the void from more than 20 billion kilometers away. Their messages take over 20 hours to reach Earth, moving at the speed of light. Their power is fading, and one by one, their instruments are shutting down. But as long as they have breath, as long as they can speak, they will continue. The legacy of Voyager is not only what it taught us about the planets, it is what it taught us about ourselves. It showed us that our solar system is more complex, more dynamic, and more beautiful than we ever imagined. It revealed volcanic moons, storm-racked giants, icy worlds with oceans beneath their crusts, and rings sculpted by gravity. It laid the foundation for modern planetary science and inspired generations of missions, from Galileo to Juno, from Cassini to New Horizons. But more than anything, Voyager proved what we are capable of, that we can build something that survives the silence of space, that endures across generations, that carries a piece of us far beyond our home. Today, the Voyagers drift through the interstellar dark, each holding a golden record, a message in a bottle cast into a cosmic sea. Maybe no one will ever find them. Or maybe, one day, a curious civilization will decode the record's greetings, its music, its images, and know that long ago, a small species on a blue planet looked up and dared to send a whisper to the stars. Voyager is not just a spacecraft. It is a statement, a hope, a living echo of who we were and who we still strive to be. And so, the journey continues.